speaker presentation with Sriya Chintalapalli, where she is going to be speaking to us about building the next ubiquitous interface. Take it away, Sriya.
Hi everyone, I'm so excited to be here and talking to you guys today. Like Heather mentioned, my name is Shreya. I'm a 17-year-old brain-computer interface and extended reality developer, and I'm going to be talking about what it means to build the next ubiquitous interface. Now, what a ubiquitous interface means, it's essentially an interface that is adopted by many. And if you could think of an example of what that looks like today, that would be the iPhone or smartphones in general. Now, this is me at around 5 or 6 years old. And what I loved back then and still do now is magic shows. I love to watch magicians. And one of my favorite shows when I was younger was America's Got Talent. And my friends, they always loved to watch the dancers and the singers and the very common acts. However, I always just liked the magicians. And the reason for that is they would come on and they would bring a problem to the stage. And what would eventually end up happening is they'd somehow solve the problem, leaving everybody very confused as to how they did so, but with their mouths open, excited, surprised, feeling a rush of emotions of excitement and confusion all at the same time. And the thing is that all of these magic acts had something in common. They started off with a hard problem typically, or at least those are the ones that I like to watch. They would eventually get to a seemingly impossible solution. And the interesting thing is the pathway to how they got there was always unknown. And they never wanted to tell us what the magic trick was. They never went back and explained the steps to get to that seemingly impossible reality. Now, as tribute to my younger self, what I'm going to do is I'm going to show you a magic trick today, but I'm going to walk you backwards and actually show the steps to get to this seemingly impossible future. The thing is that today, technology is the most advanced that it's ever been. And when we look at the interface evolution, we started off with computer interfaces, or at least that came on a little bit later, but we had these big chunky computers and they got smaller and smaller in size, and we ended up removing the external mouse and the external keyboard. And then eventually we got to the touchscreen phase. And when Apple released their products and we got to interact with touchscreen, it was undeniable in nature in terms of the naturalness to interact with that interface. But what's interesting is now, as of 2019 itself, there are about 5.1 billion unique mobile users worldwide, right? And as of 2019, there was about 7.7 billion people as the whole world's population. So there's a lot of people that have access to smartphones today. So if the interface evolution took us from these computer interfaces where we remove these external devices and have now got a touchscreen, and billions of people have access to this, or at least smartphones, my question is, what comes next? You see, we do have a problem today, even though billions of people have access to smartphones. We need to work for our technology in order for it to be able to add value to us. And what I mean by that is if, say, you wanted to read a research paper on something on Google, you would have to type in the keywords, try to find exactly what you're looking for from thousands of different sources. If you're someone who's paralyzed or immobile, you're going to have difficulty with interacting with technology because of the way that we have to interact with it today. We have to use our fingers. We have to be able to search through different options to be able to get to where we want to. It is not entirely easy to navigate, or not, at least not as easy as it can be. Now, my magic-like solution, the vision that I see a couple phases down the line of this interface evolution, is where we're going to be able to have access to all that a digital device provides us, but in thin air, without the hardware. Technology would be able to work for us by identifying what we want and providing needs instantaneously. This would allow people that are both fully abled and differently abled to interact with technology in the same way and have it add value to us. Now we have this problem and we want to get to this magic-like solution, right? But there are a couple steps along the way. And I, unlike the magicians that I used to watch, are going to tell you what those steps look like. And to give you a visual image of what that looks like in terms of this vision, if you've watched the movie Iron Man, how he interacts with different technology where it looks like it's in thin air and he's able to use his finger to interact with his interface, that's kind of what I'm talking about to some extent. Now let's walk backwards and see what it's going to require to be able to get to this magic-like solution. So The way that I think about it is, okay, we want to build this next ubiquitous interface. We think that it'll be helpful a couple stages down the line. But to be able to understand how to get there, my question is, well, what did it take to build the last one, the most recently adopted ubiquitous interface? When we look at it, in terms of the iPhone, which was the most recently adopted ubiquitous interface, and we go back to when it was first released, there's essentially three different categories that the CEO of Nurbal, Ramses Al-Kade, talks about as the iPhone became ubiquitous. So there's this niche enterprise specialized category, there's the consumer specialized category of a certain interface, and then there's the ubiquitous interface category. The interesting thing is that before the iPhone was released, other versions of smartphones like the Palm Pilot phone and the Palm Live Drive were also released. In fact, they had maybe more features than the iPhone did. They did have more features than the iPhone did. However, it was the iPhone that became ubiquitous in nature, and the iPhone was released afterwards. Why? That's quite strange. The reason for that is the iPhone had a very special quality that the other two or other competitors in the market lacked, and that was the touchscreen ability. And the reason that the touchscreen ability allowed the iPhone to become ubiquitous is because the interaction with that interface became undeniable in nature. It was so easy and natural that even a 2-year-old could figure out how to navigate it. Now, when we look at what is currently being built today in terms of the next interface, augmented reality falls under this niche enterprise specialized category. Very few people interact with it and understand what it is. It's only used for certain types of markets. It can be used for marketing today. If you use Snapchat, augmented reality is used. If you've seen the dog filter and it overlays an image onto your face, that's augmented reality. We then have the consumer specialized category. And here, one second. This is where virtual reality falls into place. We have headsets that have been released. They are available to consumers, but they're not entirely affordable and accessible to all, and only certain people are currently interacting with them. So this is a little bit of how these different types of reality work. I feel like everybody here might have a good understanding of the basics works of how augmented reality and virtual reality work. Essentially, it's about changing the current reality that you're in by digitally overlaying an image onto the current existing environment, that's augmented reality, and then changing the entirety of your sphere of realm is virtual reality, and that requires a headset, whereas augmented reality doesn't. Now, given this, the problem right now is what comes after, what will become ubiquitous. Like I said, only a certain group of people is able to access virtual reality if you have a headset at home, if you know what you can use it with. There's also a problem of people aren't able to use it for hours on end, which is why it's not able to replace the current ubiquitous product, which is the iPhone. Now, the thing is that there's some problems that the current extended reality methods lack. In order for it to become this ubiquitous interface to build that magic-like vision that I spoke about before, there's an inability to detect depth, density, and user intent. So I'll give you an example. If I was using an augmented reality web browser, where there was this web browser in front of me, it was being digitally overlaid maybe on my wall or somewhere in my room, and I wanted to use my finger and track my finger to be able to scroll down a Google Sheets document. There's a problem when I do that. I could move it just 2 inches upwards, and the detection of whether I want to scroll down 2 cells or 200 cells is difficult. Even in terms of user intent, if I want to place a certain vase on a table in a virtual reality environment, how far I want to place it, how deeply I want to place it, how much force is required to make that happen, that detection is very amateur, and that's why people aren't able to switch over to that type of interface entirely and move to that realm. Now, what I think would be able to allow us to integrate a certain technology into what's existing in terms of extended reality and make that vision possible is something called brain-computer interfaces. And very simply, what brain-computer interfaces are is it's allowing us to connect our brain to external devices like a computer. There are different brain waves that take place in our brain at different frequencies while we're performing different tasks. When we're able to detect what that frequency looks like, we can be able to then manipulate it and control an external device accordingly. So say if there's alpha waves and beta waves in your brain, and when you do a certain task, the alpha waves are in higher concentration. If I was able to detect which of the different types of waves were in higher concentration, I can maybe make a robot arm move up or down. So if alpha waves are in concentration, the robot arm moves up. If it's beta waves, then arm moves down. And so basically by tracking different waves in your brain, we can control external devices. Now, there are 3 steps involved for brain-computer interfaces to work. One is collecting the signals, second is interpreting the signals, and third is making the external response take place. In order to collect brain signals, there are 3 main different types of input that we can take in. There's a non-invasive approach, which is the first picture on the screen, where you don't have to insert anything into your brain. It's just a headset that you can wear, and the electrodes will be able to detect certain types of waves that are taking place. There's the semi-invasive, which requires partial surgery. You'd be able to detect waves where the chip in the device, it's not a chip, but the device would be able to be on your brain. It would have access to that and be able to pick up signals from there. And then the third one is the invasive method, where you require surgery, a brain implant. The brain implant would be placed inside your head, and we'd be able to pick up signals from there. All 3 are possible. It is safe to say, though, that the invasive method picks up the clearest of signals, and currently, in terms of research, that's where the most, as it relates to medical diagnosis, is taking place, because we're able to have clarity in terms of the data that's collected there most. But we can still pick up signals in the non-invasive method. And so, yeah, this is essentially what I was talking about before. This is how we're able to pick up signals, understand them, and then command the device externally. And with this integration, we'd potentially be able to get rid of all 3 of the different problems I spoke about before in terms of making extended reality being used to build the next ubiquitous interface. We'd be able to detect depth, density, and user intent without you even having to lift a finger, potentially by just understanding your brainwaves and what it is that you want. And then using those signals and that desire to be able to interpret what you want and then execute that accordingly. But today, as of right now, the integration of extended reality and brain-computer interfaces in an everyday wearable or product that is accessible, affordable, and portable does not exist. Innovation, however, is currently taking place to be able to get us there. So theoretically, it is possible, but we're currently, most organizations are still in the research phase to get us there. The main players include Kernel, Neurable, which is a startup out of Boston, Neuralink, which is Elon Musk's company, and Facebook also acquired another startup that was working in this area, neural interfaces, called Control Labs, and so we predict that they might be using that as well. Facebook is working on something called Project Aria, which are these augmented reality glasses, and maybe in the future they'd be able to integrate the neural interface technology into that to make it something that's more easy to interact with. But I'm also trying to understand the space and potentially move the needle in the future. So as it relates to extended reality, I'm currently an extended reality intern at Metaverse and have been doing work there just to understand what's going on ground in today's world, which businesses and players are involved in terms of potentially making this future a reality. And what you see on the right there, that's an article that I wrote on how extended reality is currently being used in terms of retail, and understanding how we could potentially get marketing officers to invest in technology to make it something that becomes normal. Because for us to enable a ubiquitous interface future, we need these technologies to become normal. And they are in certain ways, but the knowledge of what they are and how they can be used and the potential isn't as widespread as it should be. In terms of brain-computer interfaces, some of the projects that I've worked on to give you an idea of what's actually possible today, I built an emotional sentiment classifier. And what this means is I took online data of different brainwave signals and then was able to use machine learning to predict the type of emotion a person would feel at a given moment. And that data was taken in by understanding the emotion that people were feeling while watching happy movies and sad movies and other movies that inflicted different emotions. OpenBCI is a biosensing tools company that releases the type of non-invasive headsets that I was talking about before. And you can use that to be able to create something called a P300 speller. And what that means is it allows you to detect what type of letter you want to type, and then the computer types that letter without you having to use your hands. And that's something that I've been working on. Neurable, which is a brain-computer interface startup that I talked about based out of Boston, I was able to work with the team and get exclusive access to some of their technology and their data and build some projects there. It was NDA inclusive, so I can't talk about the specific projects, but eventually after a couple, 24 hours of a private hackathon with them, we built, my team and I built 3 different projects, and we pitched that to their CEO and their team, and was then able to get feedback on it and are now writing 3 white papers for them on that. And this OpenBCI tools company, they're going to be releasing this $10,000 partnership to give out equipment to high school students to be able to build their own projects. And I'm project managing that and helping them with that today. I've also been very, very grateful to be able to talk about this vision, the different projects that I've been building at different conferences. Today is one of them. And hopefully, as we progress in terms of both the fields and bringing them together, which is my next step as a developer, we'd be able to enable this magic-like vision future where we have access to all that a digital device can hold, but in thin air, potentially being able to interact with it using only our brain and not our hands, where both fully abled and differently abled individuals can interact with technology in the same way. Maybe like Iron Man, maybe even more than just what he can do. If you guys would like to reach out to me and say hi, feel free to. My email's on the screen. I have a monthly newsletter that I send out, which has different project updates and growth updates in terms of what I'm building. And so you can just say hi, and if you'd like to be added to that, let me know, and I'm happy to do that for you. And then in terms of recordings and demos of what I've been building, my socials are also the how to find them are beneath that little box over there on the screen, and you can see some of that there. But other than that, that's about it for today. In terms of next steps, a little sneak peek in terms of what I'm doing next, I'm going to be trying to bring both of these technologies together and build projects there. That's a little bit more difficult, and I'm figuring that out right now, but I'm looking for different places to speak about the most recent project that I'm building, which will incorporate both these technologies and understanding the difficulties in terms of bringing them together. So if you know anywhere that I'd be able to share that and talk about that, I'd love to hear. But that's it for me today in terms of building the next ubiquitous interface. I hope that I was able to share something and teach you guys something new, and I'm also happy to answer any questions.
Thank you, everyone. And thank you, Shriya. F4 clapping is clapping for Shriya's presentation. And I will assist if there are any questions in the audience. You can type them in the chat and I will repeat them back. And while folks are out there thinking of their questions, I have a question, several questions for you, Shriya, but I'll start with this first one that is relevant to the slide that you actually have up right now, which is talking about the differently able. So can you comment on how technologies addressing the needs of the differently abled are actually the in route to brain-based interfaces?
That is an awesome question. So the thing is that when we talk about building the next ubiquitous interface, it's not the most important problem today, right? So when brain-computer interfaces was brought to light, and the main players in this game right now, they are looking at how can we solve important medical issues first. And as we continue to do that, we'll be able to understand and develop the technology to such that it won't be only available for people that need it today, but also people that want it to make their lives easier. And so when we talk about building the next ubiquitous interface, that's something that comes later down the line. Our first priority today is to be able to help the people that need it in terms of a medical issue. So, for example, Neuralink is looking at depression, anxiety. We're also looking at how can brain-computer interfaces be used to rehabilitate people that are currently immobile or paralyzed by activating certain limbs through the brain signals. And then also, can we potentially restore blindness by looking at brain-computer interfaces in the retina? And so as we make progress as it relates to those that are differently abled, we'll be able to understand the technology such that we'll be able to then bring it to masses and allow it to help the lives of everyone that wants it. Also, another thing is that for people that are differently able today and are paralyzed, to have access to a computer or a smartphone, you have access to so much knowledge and so much education. And to not have that, you're actually at a huge disadvantage. You would need some assistance to be able to interact with it if you were paralyzed today. And so something like the P200 speller, where you'd be able to detect the type of letter you want to spell, and the computer can do that, it makes it easier for those that want to interact with it on their own. However, it's also important to note that the P200 speller for us cannot be an alternate to just typing because it's slower in nature. It takes longer. It wouldn't be an effective use of our time. So yes, as we make progress in terms of bringing this technology to help those that are differently abled, we'll be able to understand it better and then potentially be able to bring it to the masses.
All right, thank you. I'm going to, oh, Simon has asked if you would actually type your email address in the chat pod. Yep, it looks like you're going to do that. Great. I have another question, though, picking up on this idea of ubiquitous access. I'm trying to imagine what that would be like. and I'm struggling with it. So I'm trying to come in from other forms of technology that I can recognize. So you had some slides where you talked about what was going on with a small handheld device, and then we arrived at, say, the iPhone. Um, can you talk me through, let's say, virtual reality devices that we have right now? So currently, we're used to things like headsets and controllers. The Microsoft Kinect product went off the market. Um, we are hearing that Facebook and Apple are going to have AR glasses coming maybe within the next couple of years into our reality. So can you walk me through a few more examples of technology that you think are walking that route towards ubiquitous?
Absolutely. So I think extended reality is the main one as of right now. But in terms of other technologies, I think something that's a really important discussion to have as it relates to this space is data privacy. If anybody has watched the documentary that came out talking about the larger companies like Facebook after the social network, I think it was called The Social Dilemma, and it talked about data privacy issues just today with regards to your Instagram account or your Facebook account or your Gmail account and your interactions online when you do web searches. And the thing is that what one I think is an interesting discussion, but it's something separate, is just like considering that people have watched that documentary. I'm curious to know why, even though we know how data is being manipulated, we still choose to interact with technology in the same way. And I think that's the majority of the population, maybe not all. But despite that, it's still a concern in terms of how it can be used, sold, and manipulated to target you to make certain decisions. But all those that data that's collected when you are currently interacting with the web, that's all skin outwards. That's the type of post that you like on Instagram, the comment that you type on your friend's post about this morning's brunch. But with brain computer interfaces, if politically and economically incentivized organizations have access to what's going on inside your body, inside your brain, which you can't even interpret, you don't even understand the magnitudes of possibilities and interpretations that can be made through that, that's dangerous. And we don't even know what can be done with that yet because we're so early in terms of the field. We haven't made extreme progress as it relates to the hype cycle with neurotechnology, especially in relation to extended reality. But when we bring the two together, these are questions that have to be discussed by engineers and developers and other players in the game. But I think that a potential technology that can be used in this space is blockchain. So blockchain allows us to store our data separately and have autonomy over who we allocate it to, who gets access to it, who it's sold to, and maybe when we collect this type of data and it's being used to alter our extended reality environments, be able to create this ubiquitous interface where there's going to be a lot of data collection from the brain, we'd be able to store it in a blockchain environment where we have access to who gets access to our data and how it's being used. And we even as individuals be able to sell that data to help researchers, but we would have control over it. And I think that's an important technology to bring in along with extended reality and computer interfaces. Yeah.
Yeah, great. I like that. I'm going to think more about that in the future. I think that's a great suggestion. All right. Cindy has asked a great question. As a matter of fact, Cindy, do you want to ask your question? Do you want to come turn on your mic, or shall I read it for you?
Sure, I'll ask Heather.
Okay.
That was so impressive and wow. I just was wondering, maybe you mentioned it and I missed it, but what inspired you to do work in this area and what do you want to work on in the next 5 years?
That is a great question. So I'll answer in two parts. One, it's actually, as a kid, I mentioned at the beginning, but I love magic. And so when I started learning at school, the subjects that I was most drawn to were technology and science. So anything in that realm was the most interesting to me because the output of it, see, it seems impossible. Like the fact that a transparent tube of transparent liquid can turn into a pink gas makes no sense. Like it's magical. It's a trick that I can perform to make people gasp. And I think that that's what initially drew me to the areas, the subject areas. I just thought that it was impossible, and being able to backtrack and understand how it can be done and for there to be an actual reason or a formula or a trick, that was interesting and that pulled me in to begin with. But I think the reason that I took it up in terms of understanding it and building in that area and wanting to commit time and effort to it was because I see that it's not just about amusement and people gasping, but it can be used to solve problems. And when we look at like the world's largest problems that exist today, our greatest fighting chances in terms of understanding how emerging technologies and sciences can be used to solve them. And for example, if like we take something that we're not talking about at all today, like climate change, like there's only a certain extent of change that can happen from like organizing parades or being on the road and fighting for discussion. Ultimately, by understanding the root causes of problems, will we be able to solve problems like that and move the needle? Like, what are the largest contributors to problems like that? Who are the main players? How can we understand how we can alter the negative effects, maybe through carbon capture, carbon sequestration? This applies, like this system of thinking of first principles analysis, to solve big problems that impact billions of people, to a bunch of different problems that exist today, whether that be medically, like cancer, or environmental problems that will eventually become medical problems, like climate change. And so I've now been understanding this magical situation, me being drawn towards magic tricks and relating that to technology and sciences. I've been most drawn in now because I understand that they can be used to solve problems. And so in terms of the next 5 years, I've mostly been spending most of my time just exposing myself to the most emerging technologies and sciences, learning about them, and then trying to replicate existing projects that exist today to get a hang of it without needing a PhD, and then trying to create something of my own. And so the first ones that I started off with were brain-computer interfaces, extended reality, and artificial intelligence, and trying to be using them together. But I think that I will spend more time in the coming year, and at least the next 2, still exposing myself to what is out there. There's so many other technologies, and what's interesting when it comes to solving problems is you usually don't need one, you need multiple. So you need to be interdisciplinary in terms of understanding how they can be used together. And so there are other technologies like the future of food with cellular agriculture or quantum computing that I still want to learn about, even though I'm very interested in this area of building the next ubiquitous interface. And so I'll be spending the next couple of years exposing myself to those technologies, building things there, understanding the intersections, and then likely picking a problem that I want to solve and figuring out how to use my expertise and then bringing on new knowledge to be able to do that. But the ultimate goal is to solve problems, and I think that this is one of the most promising ways to get there. Interdisciplinary knowledge as it relates to tech and science.
Wonderful. Sriya, another question has appeared in the chat, but John, do you want to come off of mute and ask it yourself?
Sure. Thanks, Heather. Thanks, Sriya. This is really awesome. And I'm sorry if you addressed this already a bit. I just got interrupted with a phone call and didn't get to listen and participate as much. But I was just wondering what you saw as a software development kit for brain control interfaces being created, with all these different platforms across the multiverse and an extended reality. It would be so great to have a brain computer interface for accessibility. But do you see, what are the pathways? Is there a different development kit that's going to be necessary for every platform, or maybe there are pathways for addressing this interoperability? Just wondered your thoughts.
For sure. So as of right now, as it relates to integrating the two technologies together, there's very, very few people working on it. We do have some people. There's niche categories working in brain computer interfaces, and then more people working in extended reality separately. But the number of people working on them together is very, very small. A lot of it is still in research phases. So as it relates to software development kits, brain computer interfaces alone, right now it's you need to know like machine learning and artificial intelligence to be able to like interact with brain computer interfaces in an advanced way, because it's very simple. If you understand how machine learning works, it's basically you take in input data, you understand the data, you create an output, and then you can simulate different things that you want to using that at its core. And so with brain computer interfaces, you need to have, for now, as it relates to like the software that I use and how I code in it, you require to know the knowledge of Python. But other than that, I just use machine learning algorithms and models to be able to interpret data. As it relates to bringing the two technologies together, here's where it gets more complicated. First of all, you need 2 headsets. You're going to need if you're using VR, you need a virtual reality headset, and then if you want BCIs to be used too, you need the EEG headset. That's what's used to collect non-invasive brain signals. So one would have to be wearing both to be able to collect the signals and then alternate or change virtual reality environments. Another thing is that extended reality, or at least VR right now, like I code in Unity there. With BCIs, I code in Python. So those are 2 languages altogether. To integrate them together is another challenge in a way that's easy and can be done in a simple game. Like I haven't personally seen anybody work on that just yet, or something that is accessible to all people to use as a kit. I'm trying to understand how we can bring the two languages together to create something that's easy to use, but I'm trying to build it right now. So I don't know of anything that exists that can be done with both the technologies together and easily change extended reality environments based on brain signals. But I know that OpenBCI is currently trying to work on some hardware for that. I'm not sure about if any SDKs are accessible. I haven't seen any.
Wow, what trailblazing work! I mean, it's such rich a rich field for creativity and development, and a lot of interconnected expertise that you're bringing together. This is fantastic. Thank you, great answer. The machine learning thing seems like the right way to go.
All right, more questions from the audience. Want to make sure everyone has a chance? No, we're good. I think let's do one more, Shreya. And you touched on it a little bit, but it seems like we can't talk about the topic of brain-based interfaces without going a little deeper into it, and that is these concerns about privacy. So, for example, what we've been talking mostly about up to this point has been interfaces and then using things like you said to detect higher amounts of alpha waves, higher amounts of other brain waves to do control. So those are all things that are coming from the brain out. You're detecting them in some way outside of the brain, and then the user's actions can be translated into reality. But that electronic road goes two directions, so it goes back into the brain too. And you hinted to it a little bit when you said there was research on things like helping to cure depression or in some other medical fields. Um, shouldn't we all be very, very concerned that there is research going on that's going to be this invasive? What if I put on a headset and I fall asleep in it, and I wake up and I'm convinced that I live in another country and speak another language? Couldn't that happen to me?
That is so fascinating. Yes, and I think BCI is a very scary area. As it relates to, so right now, I think the people that are working on, as I mentioned, is mostly to solve medical issues as it relates to depression, anxiety, restoring blindness, restoring paralysis, mobility in those that are paralyzed. Um, Individuals and organizations both need to be involved in terms of discussion for this. I think the difficulty becomes when the individual isn't aware of like what is possible with the technology and also how it could be used against them and what the policies look like. I think that it can definitely be used to create a lot of harm, but also like other existing areas like social media and other technologies that we use today do the same exact thing, and people are aware of it yet still use it. And so a lot of it is like individual decision making, and then it's also like the ethical discussions that economically and politically incentivized organizations have. What I asked is there was so Neurable, which is the startup out of Boston I spoke about. They just released a wearable device called N10, and they're these non-invasive brain-computer interface headphones. And what they're supposed to do is for people at the workplace that want to get work done faster or more efficiently, they're being used to understand what different types of audio, that's one of the applications, allows you to focus best by tracking signals and would induce that type of sound for you while you work to make you work faster. And so I asked them during this AMA session that they have what it looks like in terms of their privacy policies. And something that they mentioned was along the lines of like when they get the data, it's automatically, the identities of the people are automatically removed. So they can use the data to be able to understand what is going to be most helpful to their users to build out features, but they don't actually know whose signals and whose data relates to which identity.
Oh, we lose Shreya's audio. Audience,
So
can you?
while
Oh,
No,
then
we can
the
hear.
data
okay.
Oh wait, no, sorry, you're right.
Sorry, Shreya, we're having your audio is coming in and out.
Sri, if you go up to the gear icon and reinitialize voice from that menu on the gear in the upper right corner.
Try it again. And There. Yeah.
Yeah. Can you guys hear me?
Now we can hear you. There you go. You're back.
Okay. Okay. I'm sorry. I was talking about the data privacy. Yeah. So as of right now, the discussion needs to be had. I don't think extensive discussion has been had on this. Yeah, but it's a responsibility of both the individual and organizations to be aware. But the example of how Neurable is using the input data to be automatically dissociated with the actual identity of an individual is an interesting approach. I also think blockchain could potentially be used. But if you have a little more time, I'm also happy to talk about other interesting applications for people that are working in virtual reality to bring this in. But that's up to you guys if you're interested.
Well, Cindy has put another question in the chat here, and Cindy, I'll just read it out for you if that's okay. She asks, how did your parents or teachers impact your pursuit in this field of study?
That's a great question. So I'll start with parents. My parents are amazing. They've always been. I think with parenting, like as it relates to like right now in this generation, there's different approaches that are taken. My parents have been very good at letting me explore and experiment and make mistakes. And so the thing is that actually within this specific field of study of brain-computer interfaces and extended reality, I've only been working in both for less than a year. So as it relates to like the entirety of my progress as an individual that has got me to here, what my parents have done a really good job at is whatever it is that I was interested in or curious about, they let me go ahead and explore it. Even if I made mistakes, even if it seemed risky at the time, they let me do it because they understand that I wanted unconventional and exceptional results in the work that I was doing, and that was going to require me to take risks and for me to make mistakes. And I think that's been the primary advantage that I've had as someone who's been working on things that aren't necessarily taught at school. As it relates to teachers in school, I think for me, as of right now, I found that I just want to pick up the pace in terms of my learning. I feel like it was going very slow at school, and at the school that I used to be at, I felt like for the projects that I was working on outside of school, I didn't feel like I could give as much time and effort into it because of extra additional requirements that were required at school. And so what I ended up doing is I moved to an online school, and I'm currently finishing up my credits such that I'll be able to finish high school a year earlier. And that's awesome because I get a lot of leverage in terms of flexibility. And that's a great thing in terms of the teachers that I currently have, giving me the flexibility and autonomy to learn as I want to and quickly, and be able to do that and such that I can give focus to the other things that I'm interested in that maybe aren't taught at school like this. In fact, there aren't even college majors right now for neurotechnology or extended reality. There are classes on the side, but not majors as such for a lot of the things that I'm interested in.
Right. We'll assist as best as we can, as I learned, to make sure that those fields begin to exist out there. Yeah, great. All right, so what I'm going to do, I think, is I'm going to actually tantalizingly hold your offer to discuss a little bit more of this to offline, and those of us here in the main stage can have that conversation with you. But I'm going to close the live stream. So before I let you go, can I get one more round of applause for Sriya Chintalapalli, who's been speaking to us about brain-based interfaces today and sharing her innovative ideas and approaches. So thank you very much, Sriya. And I'm going to come over actually, and let's see if I can do it. Can you face me and we'll do a handshake? I'm going to come towards you, and then F3 on my keyboard. I don't know if you have F3 on your keyboard. We'll try it. Trying it.
I click at F3, but nothing's popping up.
Nothing's happening. Oh, maybe your keyboard is programmed to do something else with that code. That's okay. That's okay. No worries. All right. Thank you very much. All right. So the main event has finished. We're going to stick around for a few minutes to do a few more wrap-up questions, but the live stream will now close. Thank you again to our videographers, Tony Cube Studios, and the YouTube audience. Go ahead and end the recording.